Welcome to Python Basics with EJD. We are still talking about object-oriented programming. And in this video, we focus on polymorphism and abstraction in object-oriented programming. So the goal is to demonstrate flexible, extensible design using polymorphism and abstraction so your code remains easy to evolve without ripple effects. So the big idea behind polymorphism is the next thing we want to consider. By definition, code that works with many types through a common interface rather than specific concrete classes is what we call a polymorphism. So any code that works with many types through a common interface rather than specific concrete classes. Of course, we've gone through the idea of types previously, talking about things like integer, floats, strings, and all of that. Why does polymorphism matter? Because it matters because it reduces if and elif type check trees. It improves testability where we can swap in mocks and fakes and encourages open and closed design. So it is open for extension and it is closed for modification. So everyday Python examples can be found in things like lenx, which works for strings, lists, dictionaries, custom classes with double underscore len, double underscore. And it's also, we have it in file-like objects in anything with .read, which behaves like a file. So a good example is what we call doc typing, where you have, so you define a function called dump underscore first underscore k, reader, and k is 100. And then this works for any object that has .read, that whether string or bytes. Then it returns .read underscore k, like that. So that's an example of doc typing. Of course, this is not going to produce any results. Yeah, because that's not the intention. Just to demonstrate how an example. So we have function and operator overloading in Python. So function and operator overload. Function overloading implies that Python does not support signature-based overloading like Java or C++. So for Python, it does not support signature-based overloading like Java, and it is used in doc typing, which assumes the method exists. And then we have functools.single dispatch for type-based overloading. So we have function overloading with single dispatch, like we just said up there. Okay, so you have this whole code now. Function overloading with single dispatch. So functools library is what we are using, and from functools we are calling the single dispatch. So and that is called by using at single dispatch, and you define to text X, return string X. So it's more like you're converting something to text. On the other hand, you have at to text dot register. You see, this to text here is actually the name of the first function defined. At to text dot register, and then we now say define underscore x integer, return fx that. And then you have another to text dot register. So you are turning x, which was string, to integer here. Here you are turning it into bytes. And then this is to return x dot decode, the type UTF-8 errors replace. And then imagine that you now want to print to text 1, 2, 3, 4, 5, 6. So you're turning 1, 2, 3, 4, 5, 6 into text, and you're turning hello, which is a string, into text. And then you're also turning a float 3.14 into text. That's exactly what this whole thing is doing. So it turns whatever you supply it to text, right? So in this case now, so 1, 2, 3, 4, 5, 6 here stands for X. Hello here stands for X. If I be hello, and then you have 3.14. So if you run all this, what do we get? We get 1, 2, 3, 4, 5, 6. So instead of just 1, 2, 3, 4, 5, 6, you have 1, 2, 3, 4, 5, 6. Hello becomes regular hello, and 3.14 is 3.14. But now they are text and not the string or integer or whatever they were supposed to be originally. So then we have operator overloading after talking about function overloading. Operator overloading via Dunder methods. So Python allows redefining operators for your own classes. So you can define operators for your own classes. For instance, for arithmetic, you can have double score, add, double score. You can have double underscore add underscore double underscore add double underscore. Then for sub, you have double underscore sub double underscore for subtraction. For multiplication, you have double underscore more mul double underscore and so on and so forth. And for comparison, we have double underscore eq double underscore, and we have double underscore lt double underscore. We have double underscore gt double underscore and so on and so forth. For conversion and display, we have double underscore string double underscore and double underscore REPR double underscore. So let's do a money class for as an example. Imagine that you have from data classes, you want to import data class, for instance, and you call the data class. So you say this data class frozen is true. Then you create a money class money, amount is integer. So you store this in cents, and currency is in string, that is USD. Okay, so you now have define double underscore post double underscore in itself. That's some initialization. So if self dot amount is 0, so you can raise value error because you don't want to have negative value. So money cannot be negative. That's what that raises. Then you have define another function, double underscore add double underscore self order. So the argument here is order. So if it's instance order money and order dot currency self currency, then return money self amount, the amount you have there plus the other amount you're supplying, and self dot currency will be returned. So this return not implemented, and then you have define double underscore RADD double underscore self order. So if order is 0, so in that case, that continues like that. Okay, so we define another function, double underscore equals. So all these things we listed up here, we are using all of them as much as possible. So you have its instance order money and backslash, you come down, self dot currency, order dot currency, and backslash self amount dot amount. And you define another string, whole cents, div mod, self dot amount 100, return self currency, and all that. Then we can now have a demonstration. To run that, and so I'll use alternate enter so it can open another code entirely. So if you now say M1 is money 5,000 because the original function is money, right? So we have money and we have supplied the money. So it's money 5,000, M2 is money 2005. So if you now want to print M1 plus M2, so that automatically gives us so the 5000 you have typed is going to be seen as $50, and 2500 is going to be seen as $25. So by the time you do the two together, so you can print M1 plus M2, you can print sum of M1 and M2, and you get $75 like that. So that looks a bit complicated, but you want to study the code better to get a proper understanding. So let's talk about doc typing in Python. The concept is that don't check the type, check for capabilities, right? We're talking about type, string, integer, and the rest of them. So in doc typing, don't check the type, check for capabilities, which are methods or attributes. If it quacks like a duck and works like a duck, then it's a duck. That's the concept here. And the pros are that it's very flexible and has minimal coupling. And the cons, errors show at runtime. So testing is crucial. So you need to test to be sure everything is in order, right? So example, any object with dot area is valid. So you have define total underscore area shapes. So sum, then you have s dot area for s in shapes. So you're summing up all of that. Then for class circle now, so you define that, self radius, we need radius for circle. Self dot r is r. Then you define the area pi r squared. From maths, of course, you import pi because that's where they're going to get this pi from. So you can see we are calling the library inside of the class. In fact, inside the function inside the class. Then you can also define square. For square, you just need a side so that the area can be s squared. So if you now say print total area for circle and for square, so it's like you're summing up. So you calculate the area of a circle, the area of a square, and add up everything like that. So that is the idea of doc typing, right? So we have abstract classes and interfaces. So Python's ABC module, there's a module in Python called ABC. Python ABC module enforces contracts. So you have, first of all, abstract base class ABC. That's what ABC is about. It cannot be instantiated, and it defines abstract methods that must be implemented. Then why abstract-based classes matter, right? They formalize interfaces, the module formalizes interfaces and prevents missing methods and provides reusable base functionality. So here, imagine you have from the ABC module, you are importing ABC, and you're also importing abstract method. So from math, you also import pi. So it creates a class. Class shape is ABC. So abstract method, we saw this before. I think in one or two videos before now. Then define area self. Abstract method, you also define the perimeter and so on. So for class circle now, we're talking about a specific shape. So you see the circle inherits the attributes of shape, right? So in this case now you now initialize for the radius. You have self.r is r, then you now want area, right? Define area pi r squared, that's self.r times self.r multiplied by pi that's starting it, and perimeter is 2 pi r. So if you do, let's now say c is equal to circle, they can now print c dot area and c dot perimeter. So this circle now is the class you have defined. All right, so if you run this whole thing now, so you get the area of the circle and the perimeter of the circle with radius 5. So let's talk about the mini project where we have an employee payroll system. In this case, we have some requirements. We need the abstract class employee with methods. Then we need to compute the pay and describe. Then we need concrete classes like manager and developer, and payroll system that works polymorphically with an employee type. So here, see what's happening. We have from double underscore future double underscore, you import annotations. From ABC, you import ABC and abstract method. From data classes, you import data class. So you have the domain type, data class, frozen is true. So you have class money in cents, integer, currency is string. For USD now, you want to indicate the USD using string. Then now you define double underscore post, double underscore init, double underscore self. If self.sent is less than 0, it will return an error, a value error called that money cannot be negative. And then you have the next one where you define add. So if instance other money and other currency, self.currency, then it returns money. So you have self.send plus other.send dot self.currency, then and then it can return not implemented. Well, if this doesn't work, then it returns not implemented. So then def underscore radd, you have self order. If order is 0, return self, or you return not implemented. Then you define double underscore string, double underscore self. So you have the C, just like what we did before, and you run this, and okay, yeah, that has run like that. But the results will not show yet. Then we have the abstract base class here. For the abstract base class, you have class employee ABC, name, string, abstract method, compute pay, then you get the money. Then abstract method, you describe yourself in string. So we run that also because it's building up to what we are going to go get in subsequent places. So it's more like we have a multi-level. So we are doing the classes bit by bit. Then we get the concrete classes here. So you have at data class manager employee, name, string, monthly salary money, bonus rate float 0.10, define compute pay money, then bonus cents, integer self. So you have all these plenty. So you can really sit down to study all of them. And then so of course you also have to run this so that by the time you get to yeah, we finally have the payroll engine. Now I'm skipping all this because the data set is available. This is like the project, so you can actually study it to see how it works. So, and then you can now use it to build your own thing. So you have the payroll engine, you define run payroll, employees, list employee, leading to the money. So you print payroll reports, print underscore times 40. So that will give like a kind of underline. Then you have total is 0. So money dot double underscore right, double underscore handle sum. So for E in employee, so you're now actually employees now. So you pay equals E dot compute pay, print F, E describe, and all that. So you make sure you run that also so that it's registered. So how do you know you've run something? So you make sure the green check is there. Make sure the green check is there to be sure, because they all are connected together. So if you don't run one of the cells, it's going to not work ultimately. So finally, we do the demo. So you say if doubles underscore name double underscore is equal to, it's the same thing as double underscore main double underscore as a string. Then you now have the staff now. So you have the manager. So first I have a scope. The money is 8. underscore 000 underscore 00. That's like $8,000 at 10% bonus. Then you have the developer, Bobola, the money is 80 underscore 100. Hours worked is 160. So that's $80 per hour multiplied by 160 hours. Then you have the developer, the money is 55 underscore 100. That's hours worked is 120. So you can, that's $55 per hour. And then the person worked for 120 hours. So you can then calculate run pay of payroll, run underscore payroll of staff, right? So you can see run payroll here like this. So if you run this now, we get those results. So you now see the payroll manager ASCO gets 8,800 US dollars. Developer Bobola gets 12,800 USD, and developer Depegan gets $6,600. In total, you have for your payroll 28,200 US dollars, right? So you want to study that a bit more and see how that works. So you can use it for whatever. You can now adapt it to your own situation. So you have 30.6. We have the extensions now. So you can add new rules like contractor for daily pay, introduce deduction policies like tax and pension. You can have multi-currency support with conversion. You can generate CSV Excel reports, and you can write unit tests for formulas and payroll total. So you may want to see this as an extension to that. So with this, we come to the end of this video. Thank you so much for listening. If you have not subscribed already, you want to go ahead and subscribe as much as possible. And then, of course, you can hit the notification bell also, so you can always get alerted every time a new video is released. You can also become a member of the channel by clicking on join, and you have bronze, silver, and gold access with some special privileges. All right. So ultimately, you want to like and share. So comment also so that more people can have access to the great content we have going on here till I come your way again. Keep doing Python right. Bye.